You're listening to LeadAI.dev, your daily updates on AI development. Today's topic is VAKRA benchmark reveals AI agent reasoning failures in real-world tasks. Here's a quick overview. IBM Research's VAKRA benchmark analysis reveals systematic failures in AI agent reasoning and tool usage, providing crucial insights for building more reliable autonomous systems. Now, let's ask our analyst about these developments. What's new? VAKRA benchmark exposes AI agent reasoning limitations?
IBM Research has released a comprehensive analysis of their VAKRA benchmark, revealing systematic failures in how AI agents handle complex reasoning tasks and tool usage. The benchmark evaluates agents across multiple dimensions, including logical reasoning, tool selection, error recovery, and multi step problem solving. Unlike traditional benchmarks that focus on single task performance, VAKRA tests agents in realistic scenarios where they must chain multiple tools together, handle ambiguous inputs, and recover from intermediate failures. The findings show that even state of the art agents struggle with basic reasoning patterns when tasks become multimodal or require contextual understanding beyond their training data. The VAKRA framework introduces novel evaluation metrics that go beyond accuracy scores to measure reasoning consistency, tool usage efficiency, and failure mode patterns. Researchers tested leading AI agents, including GPT-4 based systems, Claude powered agents, and open source alternatives across 1,200 diverse tasks spanning code generation, data analysis, web scraping, and document processing. The benchmark reveals that agents frequently fail at seemingly simple tasks due to poor tool selection, inability to maintain context across multi step workflows, and lack of error detection mechanisms. Most critically, the study found that agents often produce confident sounding but incorrect outputs when facing edge cases or ambiguous instructions. Previous agent evaluation methods relied heavily on synthetic tasks or narrow domain specific challenges that didn't reflect real world complexity. VAKRA addresses this gap by incorporating tasks derived from actual user workflows, including incomplete specifications, contradictory requirements, and resource constraints. The benchmark also introduces temporal elements, testing how agents perform when dealing with time sensitive tasks or when external conditions change mid execution. This comprehensive approach reveals failure modes that weren't apparent in earlier evaluation frameworks, providing developers with actionable insights for building more robust autonomous systems. VAKRA tested 12 different AI agent architectures across 1,200 real world tasks with multi step reasoning requirements. Benchmark reveals 73% failure rate in complex tool chaining scenarios where agents must use 3 plus tools. Sequentially novel evaluation metrics measure reasoning consistency, tool efficiency, and error recovery beyond simple accuracy scores. Study identifies 8 distinct failure mode categories, including context loss, tool misselection, and premature termination. Framework incorporates temporal elements and changing conditions that mirror actual deployment environments.
Thank you for that analysis. Let's move on. Who benefits from VAKRA benchmark insights for AI agent development?
AI application developers building autonomous systems gained the most immediate value from VAKRA's findings, particularly those working on enterprise automation, customer service bots, or development assistance tools. Teams developing agents for code generation, data processing pipelines, or document automation can use the benchmark's failure mode analysis to identify potential weak points in their systems before deployment. The research provides specific guidance on improving tool selection logic, implementing better error handling, and designing more robust context management systems. Development teams with 310 engineers working on agent based products will find the benchmark's categorized failure modes particularly useful for prioritizing reliability improvements. Research teams and AI safety organizations benefit significantly from VAKRA's systematic approach to evaluating agent behavior in complex scenarios. Academic researchers studying AI alignment, robustness, and interpretability can leverage the benchmark's methodology to design better evaluation frameworks for their own work. Enterprise AI teams responsible for deploying agents in production environments can use the insights to establish better testing protocols and risk assessment procedures. The benchmark's focus on real-world task complexity makes it especially valuable for teams transitioning from prototype to production systems where reliability becomes critical. Individual developers and small teams should approach VAKRA's insights selectively, focusing on the specific failure modes most relevant to their use cases rather than trying to address all identified issues. Teams building simple, single-purpose agents may find the benchmark's complexity overwhelming and should prioritize basic functionality over advanced reasoning capabilities. Organizations without dedicated AI expertise should wait for tool vendors to incorporate VAKRA's lessons into their products rather than attempting to implement the fixes directly. Enterprise development teams building multi-step automation workflows with 3+ integrated tools, AI safety researchers studying agent alignment and robustness in complex environments, academic teams developing new evaluation frameworks for autonomous systems, production AI teams transitioning from prototype to enterprise scale deployments.
Great insight, really helpful context. How to get started. Implementing VAKRA benchmark analysis methods.
Begin by accessing the VAKRA benchmark dataset and evaluation framework through Hugging Face's repository, which includes the complete task suite, evaluation scripts, and baseline agent implementations. Set up your development environment with Python 3.8 plus and install the required dependencies, including transformers, datasets, and the VAKRA evaluation toolkit. The benchmark requires significant computational resources, so ensure access to GPU instances with at least 16 GB VRAM for testing larger agent models. Download the pre-processed task datasets, which include over 1,200 annotated examples across different complexity levels and failure mode categories. Configure your agent evaluation pipeline by selecting specific task categories that align with your use case. The benchmark allows testing subsets focused on reasoning, tool use, or error recovery. Implement the standardized evaluation metrics, including reasoning consistency scores, tool usage efficiency ratios, and failure mode classification accuracy. Set up logging and monitoring to capture detailed execution traces, as VAKRA's analysis depends on understanding the step-by-step decision process rather than just final outputs. The framework provides templates for common agent architectures, including React, AutoGPT-style systems, and custom tool calling implementations. Run initial baseline tests using the provided reference implementations to establish performance benchmarks for your specific agent architecture. Execute the full evaluation suite in batches, as complete runs can take 6-12 hours depending on your computational setup and agent complexity. Analyze results using the included visualization tools that highlight specific failure patterns and suggest targeted improvements. The benchmark generates detailed reports showing where your agent fails compared to human performance and other baseline systems, providing clear direction for iterative improvements. Access VAKRA repository on Hugging Face and install Python 3.8 plus with Transformers library. Download 200 task dataset and configure GPU environment with 16 GB plus VRAM for model testing. Select relevant task subsets reasoning. Tool use, error recovery, matching your agent's intended use case. Implement standardized logging to capture step-by-step decision traces for failure mode analysis. Run baseline tests first. Then, execute full evaluation in 2 to 4 hour batches to manage computational load use, included visualization tools to identify specific failure patterns and prioritize improvements.
That's a very interesting point. Tell us about competitive context. How VAKRA changes AI agent evaluation standards.
VAKRA represents a significant advancement over existing agent evaluation frameworks like HumanEval, or domain-specific benchmarks that focus on narrow task completion. While traditional benchmarks measure whether an agent can solve isolated problems, VAKRA evaluates the entire reasoning process, tool selection logic, and error recovery mechanisms that determine real-world reliability. This comprehensive approach reveals weaknesses in agents that perform well on simpler benchmarks but fail when faced with multi-step workflows or ambiguous requirements. The benchmark's emphasis on failure mode analysis provides actionable insights that generic accuracy metrics cannot offer, making it more valuable for practical development. Compared to proprietary evaluation methods used by major AI companies, VAKRA offers transparency and reproducibility that enables broader community participation in agent development. The open source nature allows researchers to understand exactly how agents are being tested and to contribute improvements to the evaluation methodology. This contrasts with closed evaluation systems where the testing criteria remain opaque, making it difficult to understand why certain agents perform better than others. VAKRA's detailed failure categorization also provides more granular insights than high-level performance scores, enabling targeted improvements rather than general optimization. The benchmark's limitations include its focus on English language tasks and tool-based workflows, which may not fully capture the challenges of agents operating in other domains or languages. VAKRA also requires significant computational resources for comprehensive evaluation, potentially limiting access for smaller research teams or individual developers. The benchmark's complexity may overwhelm teams looking for simple pass/fail metrics, and its emphasis on failure analysis might discourage adoption by organizations preferring to highlight successes rather than weaknesses. Provides comprehensive reasoning evaluation vs. Narrow task completion metrics in existing benchmarks, open source transparency enables community contribution and reproducible results. Detailed failure categorization offers actionable insights beyond simple accuracy scores limited to English language. Tool based workflows, which may not cover all agent use cases.
Good analysis. Let's continue. What's next? Future implications of VAKRA benchmark research.
IBM Research plans to expand VAKRA with multilingual support and domain specific task categories, including scientific research, creative workflows, and specialized professional tasks. The roadmap includes integration with popular agent development frameworks like LangChain, AutoGen, and CrewAI, making it easier for developers to incorporate VAKRA evaluation into their existing workflows. Future versions will include real-time evaluation capabilities that can assess agent performance during live deployment, enabling continuous monitoring and improvement. The research team is also developing automated failure mode detection that can identify potential issues before they impact production systems. The broader AI development ecosystem is likely to adopt VAKRA's methodology as a standard for agent evaluation, potentially influencing how major AI companies assess and improve their autonomous systems. Academic institutions are already incorporating VAKRA into their AI curriculum and research programs, suggesting it will become a foundational tool for training the next generation of AI researchers. The benchmark's influence may extend to regulatory frameworks as policymakers seek standardized methods for evaluating AI system reliability and safety in critical applications. Long-term implications include the development of more reliable AI agents as developers gain better tools for identifying and fixing reasoning failures. The benchmark's emphasis on systematic failure analysis may accelerate the transition from experimental AI agents to production-ready systems that can handle real-world complexity. However, the increased focus on failure modes might also slow adoption as organizations become more aware of current limitations, potentially leading to more cautious deployment strategies in critical applications. Multilingual support and domain-specific task categories planned for 2024 expansion integration with LangChain, AutoGen, and CrewAI frameworks to streamline developer adoption, real-time evaluation capabilities for continuous monitoring during live deployment, automated failure detection systems to identify issues before production impact.
Great analysis. So, what are the key takeaways from all of this?
VAKRA benchmark reveals 73% failure rate in complex multi-tool agent scenarios, highlighting critical gaps in current AI agent capabilities. Systematic failure mode analysis provides actionable insights for improving agent reasoning, tool selection, and error recovery mechanisms. Open source evaluation framework enables reproducible testing and community-driven improvements in agent development standards. Real-world task complexity requires new evaluation approaches beyond traditional accuracy metrics for reliable agent deployment.
And what market signals should our listeners watch for?
Agent reliability standards emerging. VAKRA's systematic failure analysis approach is becoming the gold standard for evaluating AI agent reliability, with major tech companies adopting similar methodologies. This shift indicates the market is maturing beyond prototype demonstrations toward production-ready systems that can handle real-world complexity. The emphasis on failure mode categorization suggests increased focus on AI safety and robustness, potentially leading to new compliance requirements and certification processes for autonomous systems in critical applications. Open source evaluation momentum. The release of VAKRA as an open source benchmark signals growing demand for transparent, reproducible evaluation methods in AI development. This trend challenges proprietary evaluation systems and democratizes access to sophisticated testing frameworks, potentially accelerating innovation in agent development. The community-driven approach to benchmark improvement may become the preferred model for establishing industry standards, reducing reliance on closed evaluation systems from major tech companies. Enterprise deployment caution. VAKRA's findings about high failure rates in complex scenarios may slow enterprise adoption of AI agents in critical workflows, as organizations become more aware of current limitations. This increased scrutiny could benefit companies that prioritize reliability over flashy demonstrations, creating opportunities for vendors focused on robust, well-tested agent solutions. The benchmark's detailed failure analysis provides enterprises with better tools for risk assessment, potentially leading to more selective but ultimately more successful agent deployments.
What should developers and operators do with this information?
Implement VAKRA evaluation pipeline for current agent systems within 2 to 4 weeks to establish baseline performance metrics. Focus improvement efforts on high-frequency failure modes identified in benchmark results, particularly tool selection and context management. Integrate VAKRA-style evaluation into CI/CD pipelines for continuous agent testing before production deployments.
establish monitoring systems based on VAKRA failure categories to detect production performance degradation in real time.
Thank you for listening to leadai.dev. Stay tuned for our next daily updates in this rapidly emerging market.